Hello students, welcome to RD Chemistry. Here I am going to discuss about the mole concept. What is mole? Mole is the amount of the substance containing Avogadro number of particles. What is the Avogadro number? Avogadro number is 6.023 into 10 power 23 particles. These particles can be atoms, particles can be molecules, particles can be ions, particles can be anything. It can be proton, neutrons or electrons. I'll take 1 mole of sodium, 1 mole of sodium metal. 1 mole of sodium metal is made up of atoms. Therefore, I'll write in terms of atom, there are 6.023 into 10 power 23 sodium atoms. And what is the mass of this one? And this mass is equal to gram atomic mass of sodium. Atomic mass of sodium is 23. Gram atomic mass is equal to 23 grams. So mass of this substance which containing Avogadro number of particles. I'll go for 1 mole of the sulfuric acid. 1 mole of sulfuric acid. Here hydrogen atomic mass is 1. Sulfur atomic mass is 32. Oxygen atomic mass is 16. Then number of atoms are multiplied. So we'll get 98 grams of sulfuric acid H2SO4. Now H2SO4 is a compound actually. It is made up of molecules. How many molecules are there? 6.022 into 10 power 23 H2SO4 molecules are present. So many molecules are present. How many atoms are there? If we take simply one molecule of sulfuric acid, 2 hydrogen atom, 1 sulfur, 4 oxygens. There are altogether 4, 5, 6, 7 atoms are there in one molecule. If we go for 1 mole, 7 moles of atoms are there in the sulfuric acid. So mole to mole or 7 into each mole contains 6.022 into 10 power 23 atoms are present. Okay, or there are 2 moles of hydrogen atoms, 1 mole of sulfur atom, and 4 moles of, and there are 4 moles of oxygen atoms are present. All of them put together, there are 7 moles of atoms are present. Okay, fine, clear? Now let me take 1 mole of carbon dioxide. 1 mole of carbon dioxide. Carbon dioxide is a gas. If we take 1 mole of carbon dioxide is made up of molecules, correct? Then made up of atoms. So there are 6.022 into 10 power 23 carbon dioxide molecules are there. How many atoms per molecule? 1 mole of carbon is there. 2 moles of oxygen atoms are present. So I'm writing in terms of atoms. Altogether, how many moles atoms are there? 3 moles of atoms are present. Correct? Also equal to, what is the mass of this one? Carbon atom mass is 12, oxygen atom mass 16. So there are 44 grams of carbon dioxide can be connected. And this is a gas. You know that at STP condition, 1 mole of any gas occupies 22.4 liters at STP. Okay, this is the old convention. According to new convention, it is a 22.71 liters at STP. For competitive examination, this number doesn't matter because we are doing the approximation. Okay, or it is a 22,400 cm cube at STP or 22,400 ml at STP, one and the same, or 22.4 into 10 power minus 3 meter cube at STP. Okay, fine. With this, we can solve some problems, right? Yeah, see this question. A sample of aluminium has mass 54 grams. What is the mass of the same number of magnesium atoms? We'll have to connect. Okay. Aluminium, its atomic mass is equal to 27, and magnesium atomic mass is equal to 24. We have to remember. These are atom masses, not atomic numbers. Okay. Now, how to connect? We'll connect with the simple term called as the mole. We'll calculate number of moles here. How to calculate the number of moles? Given mass divided by molar mass. What is the given mass for the aluminium now? It is 54 grams divided by the atomic mass, molar mass 27. So 2 moles are there. There are 2 moles of aluminium atoms are present. Now I want to calculate now 2 moles of magnesium now. 2 moles of magnesium. If I take 1 mole of magnesium, 1 mole of Mg, it is equal to 24 grams. Therefore, 2 moles of magnesium is equal to how many grams? So that will be equal to 48 grams it will be. Okay, fine. Question number 2. 5.6 liters of oxygen at STP contains dash atoms. So oxygen, they give in terms of liter means the gas, oxygen in terms of gas they mentioned. So I'll take 1 mole of oxygen gas, which is equal to, if in terms of mass, it is 32 grams. But mass is not interested. We are interested in the liters and atoms. Is equal to, how many molecules are there? Because oxygen gas contains molecules 2 into 10 power 23 molecules are there. And this is equal to 1 mole any gas occupies 22.4 liters at STP, correct? But they're asking for atoms. I'll convert this into atoms now. This 1 mole of O2 contains 2 moles of oxygen atoms. 2 moles of oxygen atom. Therefore, 6.022 into 10 power 23 into 2 oxygen atoms are equivalent to 22.4 liters. Therefore, 5.6 liters will contain how many atoms? So we cross multiply 6.022 into 10 power 23 into 2 into 5.6 divided by 22.4. On simplification, all these will be getting a answer approximately 3 into 10 power 23. Okay, atoms of oxygen. That's fine. Next question. Caffeine has molar mass 194. It contains 28.9% of by mass of nitrogen. Number of nitrogen atoms in one molecule of this caffeine is. Okay. This caffeine contains nitrogen, correct? Then percentage. 28.9% by mass. By mass means I can take it 28.9 gram by mass dimension. Percent is always out of 100. If I take 100 percentage of caffeine, there is a 28.9, or if I take 100 grams of caffeine, there is 28.9 grams of nitrogen present. Okay. Now, when I say molecule is obtained from the molar mass. Okay. Now, molar mass 194. If I take 194 grams of the caffeine, how many nitrogen atoms will be there? Sorry, how many grams of nitrogen will be there? For that, we need to cross multiply. 194 into 28.9 divided by 100. So that will be equal to 56 grams will get of nitrogen. Okay. Question is number of nitrogen atom present. If I take one nitrogen atom is equal to 14. Okay. If I take 1 mole of nitrogen, 14 grams I can say, no? Correct? Then we convert into atoms. Okay. Say 14 units. 56 grams are there. Okay. How many atoms should have been there? So it is like a given mass of the nitrogen divided by atomic mass of nitrogen 14 is equal to 4. That means one molecule of caffeine has 4 nitrogen atoms. Okay, fine. Fourth question. The volume of carbon dioxide produced at STP by the complete decomposition of 9.85 grams of the barium carbonate. For such questions, we'll have to write down the balanced equation. Okay. So you know that barium carbonate BaCO3. On heating to produce a barium oxide plus carbon dioxide. Correct. We'll calculate the molar mass of barium carbonate because it is in terms of grams of barium carbonate. Barium atom mass is 137. Carbon is 12. Oxygen is 16 to 4, that is 48. So total it will be equal to 197 gram per mole. So if I take 197 grams of barium carbonate, it will give 1 mole of the carbon dioxide. But we are interested in the volume of carbon dioxide. 1 mole of the carbon dioxide occupies 22.4 liters at STP. So we connect mass to the liters. So the given is 9.85 grams of the barium carbonate will produce how many liters of the carbon dioxide. So we'll cross multiply 9.85 into 22.4 divided by 197, that is approximately equal to 1.12 liters. Okay, fine. Hope this is clear to you. If you like the videos, please do subscribe, share and like the videos. Thank you for watching. Have a nice day.